Hello, welcome back to Python. Now finally we had to Matplotlib. A tutorial I wanted a long time before. And yeah, today is the day we are covering it. Yeah, why Matplotlib? In our previous videos about data science, we made a lot of stuff regarding altering data, altering statistics, or creating sheets, creating charts and scales, and now what we're gonna do, we want to visualize them, and our new library serves as a visualization utility, so we can visualize simple graphs, linear functions, polynomial functions. We can create pie charts, histograms, bars, all stuff like that. And with that in mind, let's start first of all installing Matplotlib. If you're using PyCharm, you can just type in Matplotlib, move your cursor above the word Matplotlib and click on install. If you wanna do it with pip install, just write pip install Matplotlib. But in this series we are mainly focusing on pyplot, so Matplotlib pyplot, which will be automatically installed if you install Matplotlib. And you can do it like that, or you can from Matplotlib import pyplot. You can do it like this. We do it like import Matplotlib pyplot as plt. So what we also need is NumPy. We covered it in another series. I will, everything we need from NumPy I will explain as shortly as possible. So if you want to know everything about NumPy on a full extent, I recommend to watch any video regarding NumPy. But for now we just need the basic stuff out of NumPy, and it's really easy to explain it quickly. So what are we gonna look first? First we wanna create a little diagram with plot. And first let's do the easiest kind of diagram, which is just a few points. So we can also do it as a list. But instead of a list, let's do a NumPy array. Like this, which is just a one-dimensional array containing 6 different values. And now we wanna plot it, so we wanna make a diagram based off this values in a diagram. And this is the y-axis, and the x-axis will generate it automatically. So let's just do plt, which is for pyplot, plt.plot. And as an argument we use our I. And what we also should do is we should show it so you can look at it. You see, let's run it. Oh, I'm in the wrong script. Let's run it. So here we go. We have our figure, and starts from 0 at the first element. On the x-axis we get 4 because we have a 4. Of course at point 0 we have 1, not 0, because there our y-axis value at 0 is 1, then we had it to 4, and 6 like in our list, and or in our array, and last but not least 14, because we wanted to make a huge jump at the 4. Okay, I put it on the right as a small one. So of course we can define our x-axis like this. has to be fitting to our y-axis, I-axis. Let's do 1, 3, 5, 7, 9, 11. Oh no, that's one too much, I guess. Yeah, 5 values to 5 values, and yeah. Now we have our second argument, which is x. Let's again run the code. Now, as you can see, our new graph looks like this, simply based on the fact that first of all we are putting the x-axis and then the y-axis. This was totally stupid. Now let's do it again. On our code. Yeah, that's what I was looking for. Now it's comparable to our first graph or first diagram, but yeah, of course, like I said, at x1 we get 1, at x3 this time, because the second value of our x-axis is 3, we get the 4, and so on. So now let me show you a little problem that can occur. Let me alter our values a little bit. First of all, let's just take out the x. Yeah, I will pause the video. 1 second. Okay, I altered it, so now let's rerun our code. And yeah, a problem that can occur is that this is hard to be read by a human. We don't even know how much values this graph shows. So what can we do? We can add a marker. So if we use as an argument marker equals O and 1 again, now we get these little dots. Each represents a value or a point on our graph. And yeah, makes it, in my opinion, much more readable. But yeah, there are many options how you can use these markers. You can use an X. This will look like this. You can use a star, my favorite, by the way. I mean an asterisk. But of course it will look like a star. Beautiful, in my opinion. If we want a diamond shape, we type in D, like here. And yeah, other possible ones are a point for a point. You can use a plus sign for plus. You can P for a pentagon, H for an hexagon. You can use 1 for a triangle down. You can, what else? You can do a pixel with a comma sign, and you can use an S for a square. Many possibilities. If you're really interested, you can just Google it. It's pretty easy to find. If I won't forget it, I will put a link in the description below. And if I have forget it, please write a comment and I will add it. Okay. What we also can do, we can use a format string. For example, we already know D is for a diamond shape. Now let's add a colon and let's add an R. And yeah, let us see what happened. Nothing? Yeah, because I forgot to erase the argument name, because here, bam, that is what happens. Now we used an argument which is a formatted string, which defines first of all the shape of our markers, which is diamond, then the shape of our lines, which is now a dotted line, and yeah, last but not least, we defined the color of our graph, which was red. So default one is a solid line. Like already said, you can do a dotted line. You can do a dashed line like this, or you can even do a dotted dashed line like this. No, like this. Come on, like this. And yeah, this is a dashed dotted line, for example. colors can be R for red, G for green, B for blue, C for cyan, M for magenta, Y for yellow, or I for yellow, K for black, and yeah, W for white. What we can do next, we can define our marker size, MS. M is for marker, S for size. Let's do a 15. Run our code again. Bam, the markers got much bigger. To be honest, I don't know what the default size is. I guess around 4, or even it's depending on the values. I don't know it. But yeah, you can edit it with MS. If we want to define a marker edge color, so there is an edge around there's an edge around our markers, like in, yeah, let's do it in not in black and white, or white would be totally stupid. Let's do black. Now let's see this. Yeah, you see the black line around our markers. And yeah, also the marker face color equals, let's do white. What we did now is we changed the color of the markers to white. So yeah, marker face color for the markers, marker edge color for the edges, and yeah, red is the overall, the default value, because we set it in our formatted string. If you want to change your line style differently, you can just add the line. You can, yeah, line style equals dotted. Let's do the default one. Let's do dotted. Let's see what happens. Now the line style is also dotted. Will give us a warning in the console because, yeah, we defined it in the format string and then again. But yeah, that's possible. Or in short, you can also use a character. Just can line ls was it. Let me have a look on my script. Yeah, it was ls, and then we can type in our character to make it even shorter. As you see, works the same. And yeah, line color, I don't need to show it, I guess, but line color, in short LC, is standing for the color of the line, so we can do it manually as well. Can be useful if you want, yeah, have something like our I values, and yeah, just want dotted lines without any markers. Or line ls equals, you can do it like this. Yeah, and that's it. I hope you liked the video. How do you think about putting the graph on the right side so you can see our outcome? Please leave a feedback in the comments if you want, and yeah, see you next time. I will show you how to add labels, how to rename the certain values, and yeah, but this knowledge should be enough for your first visualization of data. And yeah, hopefully see you in the next video. And with that in mind, I would like to show you some outtakes, but yeah, I didn't have anything for today. Maybe I will add a stupid joke at the end. See you, bye bye. Yeah, bye bye. Hello, and yeah, welcome back to the next and second part of the Python tutorial series about Matplotlib. Yeah, last video we created our first graphs. I showed you some ways of visualization, and now we want to name certain stuff. We want to create our own labels for the y-axis, for the x-axis. We want to set title, and yeah, we want to create our own fonts for that. So let's start. On the right side, bottom right side, you see our graph here. I'm kind of resizing it. And yeah, first of all, we want to give our baby a name. And yeah, that's pretty simple. Just type in plt.title and then a string, which is of course the title, like, okay, let's call it boredom, my boredom during the day. Boredom boredom during the daytime. Now let's run the code. And you can see, yeah, boredom during daytime as a label above the graph. We can use another input like log equals left, 1 again. Now as you can see, okay, 1 again. As you can see now the title is on the left side. What you can also do, you can name the x and the y axis like plt y label equals possibility to fall asleep in in percent, and let's do the x label, which of course is for the x-axis, which can be 1 divided to 19 of the day, because we have 19 elements. Okay, let's 1 again. Let's 1 again. Okay, I did something entirely wrong. What was this? Yeah, I wanted to say x label, but kind of hit the wrong function. Here now we have labels for possibility to fall asleep in percent if you kind of move your head about 90 degrees, but clearly visible is the name of the x axis. So now let's create some fonts. Let's say font T equals, now we have to type in a dictionary. Family, not that, family, color and size. Let's add 3 different fonts like that. And now we have the keys, or in this case we only created sets. So in this case Arial, serif. Don't really know the English words, I'm kind of doing it by instinct. Let's again serif, color, dark green, not dark cream, dark green, size equals, come on, 12. Red, yellow, size equals 14, 15. So now let's make the font names more individually, like this. You shouldn't name your variables like this, I'm just doing it because it's just a small tutorial video. Okay, and now you can use a new argument in the label, font equals, for example, fonty, font equals fontie, and font equals fontie. Now let's try it out. Okay, what is unexpected? Okay, the argument name is not font but font dictionary. Okay. Have a false memory, I guess. Or maybe it's a Mandela effect. Yeah, here we go. Of course, yellow is hard to see. Let's use black. Really uncreative, but let's use black. Try again. Here we go. So now we have different labels, different colors. even different families and different sizes. Okay, that's it for today. Today a little shorter video. I hope you still could enjoy it. Yeah, I didn't want to talk too much about it because it's a really simple topic and something that's easily to Google. So yeah, have fun at coding. See you in the next video. Wish you a wonderful evening, dinner time, lunchtime, whatever time it is in your country. See you and bye bye. Hello, and yeah, welcome back to Matplotlib. Welcome back to a Python tutorial regarding Matplotlib. And yeah, let's start with our today's topic, which are grids, or to be more specific, the grid function. Again, yeah, smaller tutorial compared to the following ones. And yeah, like again on the, you see the code we wrote on our last two tutorials. We added a graph and yeah, labeled the x-axis, the y-axis and the plot, the title. Now we want to add a grid. So yeah, a grid is simply a grid, like the function already is suggesting. Not good, grid. Pretty simple. If we now run the code, we have a grid, as you can see, and yeah, on every occasion the x-axis shows us a value, a line of a grid, or the grid starts, or a line for the grid starts, and the same goes for the y-axis. Here at 2 a line for the grid, at 4 you see another line, at 6 another line, and so on. You can also define which axis should get the lines. For example, you can say axis equals y, run the code, and now only the y-axis got lines. The same of course goes for x. Here we go, now the x-axis has the lines. And yes, next to that we can also define the color of the lines, like using the argument color equals dark red. Again, let's run it. Now the lines got dark red. ls or line style, we can use line style or ls equals colon, bracket is missing. And yes, again, let's run the code. Now you can see, let me make the picture a little bit bigger. You can see the dotted lines here. Here are many dots. And yes, you can also define the width of the lines. So if you want really fat lines, really big lines, you can say line width equals, let's do 5. Which I wrote entirely wrong. Let's do it again. Yeah, now we get, oh, I'm totally stupid. I added the line width at the plot. We don't want that there, we want it here, line. So first let's delete it. Now we can add line width, oh, I got it right, equals 22. Whoa, that's a little bit too much, but who cares? And bam, yeah, because yeah, we used such huge dots, an entire dot is covering kind of a value. Let's do 4 to get a more real grid. Yeah, like this. Now we got a real grid. Still not beautiful, but I wanted to show you how you can alter the grid lines while altering the width. And with that in mind, we are already finished for today's topic. Pretty short, but yeah, easy. If you have any feedback, advice, please leave a comment. And yeah, apart from that, I wish you a wonderful evening, dinner time, night time, whatever time it is in your country. See you and bye bye. Hello, ho ho, and yeah, welcome back to Python with another tutorial of the Matplotlib series. And yeah, today we're gonna look at the scatter function, drawing a scatter plot. Yeah, which means we have multiple elements which can be represented in our graphic. And yeah, instead of a line graph, we simply wanna place a lot of dots, like little points. And we can already delete the plot function because now we want to use the scatter function, plt scatter. Starting with the x-axis and then the y-axis. And if we will start it like this, you will raise an exception. It will raise an exception, as you can see here, because x and y must be the same size. So let me count. So the first one is 19 values, so let's add another 14 values. I hope I counted it correctly, but we will see now. So before explaining more, let's just run the script and then I can explain what you see. And yeah, in this case to be okay, let's run the code again. And yeah, let me make it a little bit bigger. So let me show you it by showing you the list. And yeah, now the 1 second. As you can see here, here are the values which represent the coordinates. We have, for example, coordinate for .11, 3, 4, 5, 6, 7, 6. And as you can see here on our graph, we have 7, 6, and yeah, the lists represent coordinates. And on each coordinate, each list had 19 elements, and now we have 19 dots. Each represents a coordinate he made out of the coordinates we had as an array. Okay, let's get back to our usual size. So, what will happen if we use our scatter function again? Plt point scatter. Using two lists as an input. As you can see, and that's kind of interesting, we got 2 new points, and yeah, the points are now in orange color. Like most of the functions you can use your own color, like color equals dark red. And now we should get dark red dots. Let's see. Here we are. And yeah, so the coloring goes like any other function in Matplotlib where you can colors. Now let's create size, which is also a NumPy array. Which list is E for E in X, E multiplied with 10. And now when we have our next scatter, we can use the size argument, which is just S. And with our size argument we can define the size of our dots. And if we want to set individual sizes for each dot, we can use a list or a NumPy array as an input, like the array we created here. It's just important that we have 19 elements in the y and in the x-axis, so our list should also contain 19 elements representing a size for each dot at the coordinate. So yeah, let's do as equals sizey. See what happens. Now you can see the dots have different sizes depending on what we created in sizey. One last little thing, if you want some transparent dots, you can use the alpha argument, and this argument takes a float point. For example, you can do 0.7, one again, and that doesn't change anything. Let's do 0.4. Okay, I'm stupid. The two little dots got more transparent, but let's do the same for the big dots. As you can see, they got more transparent. And if we do alpha like 0.1, they are really nearly invisible. And of course you can combine your alpha, your color, your size, any combination. You can use a list to color or size each element individually, or you can just type in one value like we did it here, and each dot will get their own value, own color, own alpha, own size. Do it however you want. And you can simply, if you created NumPy arrays that are containing thousands of elements, if you want each individually depending on the size, for example, you can use list comprehensions. You can do it like this, or if they should have different colors, you can create colors procedural. Many opportunities, and with that in mind, today's topic is finished. I wish you a wonderful evening, dinner time, night time, whatever time it is in your country. See you, bye bye. Hello, and welcome back to Matplotlib. Welcome back to Python. Today we are looking at or creating multiple charts or multiple graphs using the subplot function. And for that, let's delete most of the stuff, or let's create a new script for that, so we save our old stuff, which has one sign, I don't know. Okay, let's do it. First of all, let's create two x and two y axes. First, one y-axis equals 1, 2, 3, 4, 5. The y-axis 1 equals 4, 4, 4, 3, 1. Then x-axis 2 equals 1, 3, 5, 7, 9. And y axis 2 equals 1, 1, 1, 1, 2, 3, 5. Yes. And what we are gonna do now, we wanna use the subplot function instead of the plot function. We will use plot anyway. We will first use plt point plot x-axis 1, y-axis 1, and plt point plot x-axis 2 and y-axis 2. But what we're gonna do, we wanna use the plt subplot without the s, subplot, and this has a different input. First of all, if we have two graphs, how we wanna align them? How do we want to put the one above and the second under the first one, or do we want each the second one next to it? So do we have, for example, if we have 3 graphs, do we want to have one line of graphs, or 3 graphs all on the same level, or should the first one at the top, the next in the middle, and the third on the bottom? And for that we first say one line, and 2 columns, and this is the first element of our kind of slice, however you wanna call it. And subplot again, now 1, 2, but now we have the second element, so it's another 2. And with that, let's just click on show. Here we are, here you go. 2 plots. Here we go. Like you maybe expected, 2 different plots, 1 line, 2 columns. We can do the same using columns, like or using 2 lines, but 1 column. Just have to exchange the order of our numbers. So let's 1 again, and now, and now. They look a little bit different. This is just based on the fact that he has now much more space using the x-axis and much less space using the y-axis. That's why the graphs look a little bit different, but if you read the certain values, you get the same results. Now the title, if we will just add 1 title, like, and the same goes for any other for lines as well. If we type in plt point title, hell no, and plt point, let's write it here, plt point title, hell yes, and plt point subtitle, or subtitle maybe, hell yes, hell no. I just missed it, has to be subtitle. And if we now run our script again, we get hell yes and hell no. The hell yes is a little bit covered by the graph. If we make it larger, here you see hell yes is 1 title, hell no is 1 title, and hell yes, hell no is the overall title. Let's do it again smaller. And what I want to show you at last, didn't ever try it out, but as a kind of finisher, let's do 16 graphs. Let me just copy that, but without the titles. Like this, and we don't even need a subtitle. Copy that. For of course we have 4 4 1 4 4. Let me pause the video. I will just create it and get back. So okay, kind of created 16 graphs. Let's run our code. And I made something entirely wrong. Forgot to make them. Okay, let's do it again, and here we go. That's what I wanted to see. 16 individual graphs. But I should kind of add some size to make it better, to add better visibility. Not that much size. Here we go. 16 graphs, so this is all possible. Kind of made everything on my own. Here again you see the code. And yeah, what would happen if we have some with the same element? Let's do that as kind of a wheel finisher. As you can see here, he just gets, the line gets a different color, and yeah, they are put again in the same graph, yeah, with different lines. One got orange to makes it much easier to decide here. Here you see it. Yeah, with that in mind, I'm finished for today. I wish you a wonderful evening, dinner time, night time, whatever time it is in your country. See you and bye bye. Wrong button. Hello, yeah, and welcome back to Hello ho ho, and yeah, welcome back to Hello, yeah, and welcome back to Python. Welcome back to another video regarding Matplotlib. And yeah, today we are gonna look at legends. And yeah, to be more clearly, a legend, you can define it as a kind of area or an element describing the elements of the graph, where you can like a little dictionary, but not the dictionary as a data type, the casual dictionary, where you can look which kind of line means, for example, the growth of your income, for example, if you have multiple lines or multiple dots. Yeah, so let's just try something out. What will happen if we type in plt point legend and run our code? So let's give legend some arguments. Let's, for example, use what are the dots? Let's do high grades and low grades. Kind of a placeholder, to be honest, but yeah, should do its thing. And I'm totally stupid. I mean, the arguments needs legend, not show again. And here we go, high grades, low grades. Here you see the larger dots are high grades, the smaller dots are low grades, and we kind of miss the small blue dots. So let's add another label. Just add another string. I don't know grades. Let's run it again. And let me think, why does this? Oh, okay, I get it. There are only two types of dots. I'm totally stupid and didn't see it. There are the blue dots and the dark red plots. And the size of the dots is created randomly. So yeah, I guess he's kind of using the average size for the legend. So what works for scatter also works for line graphs. So let's do the same with the line graphs. So in this one I created another one. Here we go, and let's see what legend does with it. Let's do plt point legend, and again we have two graphs, so we need two strings like I don't know and I know right. And let's run our code. And here we go. I don't know, you can see the color, you can see the markers, and if it's the form of the lines, because the one got points or dots as lines and one got underscores, or in this case usual minus signs as lines. We can also kind of decide where the legends are shown. For example, we can say log equals upper left. Again, if we run the code, we see now it's on the upper left. The space between our different two legends can be easily decided. Just add the argument label spacing equals 2. Yeah, and now you've seen the label space has increased. With font size, you can, choose the font size. Font size equals, let's do 20, see what happens. So this happens. You can change the face color. It just means the color of the, of our legend, of the background. Let's do it to green. I just wanted to type white because, kind of sleepy. You can add a shadow. Shadow equals true. Like this. Now you can see a little shadow, just for a stylish reason, I guess. And that's it for today's video. I am thinking about making another, because the topic can be more advanced. But that maybe after I covered other videos I will kind of do a legend part 2. And but for today's video this should be it. See you in the next video and have fun with my stupid outtakes. Yes, and this is the part where I realized I don't have any outtakes, because they were from another video. So let me tell you a little joke. When you didn't do your homework, you said you should take. Okay, now I got an outtake, but kind of. I mean, when you are talking to your teacher and telling you don't have homework, say, "My dog ate my homework." The teacher will say, "But it was a coding assignment." And then you can say, "I know, he took 8 bites." Okay, goodbye. Hello ho ho, and welcome to another episode of Python and another episode of Matplotlib. And in our last videos we focused on line graphs and scatter, but in all it were linear functions or at least continuous functions. Okay, first let's define a list that we call values equals 1, 5, 6, or no 4, 1. And then let's do plt point bar values and plt point show. And now if we click on 1, we get an exception because we are missing the height, which just means he kind of interpreted the first values as the x-axis. So we meant that we wanted the bar values to be 1, 5, 4, 1. So let's add something like names equals John, Michael, Ed, and Bob. Now let's type in names, comma, and values, and there we go. On the right bottom you can see the bars. If we add an h to the bar function, just bar h, which means bar horizontal, pretty simple. Now our bars are horizontal, and like in our previous videos we can edit the width pretty easily. Let's do some thinner bars again after running. Okay, the width argument won't be working like that if we have a horizontal bar, but now we did it just for a common graph. So we didn't know that either, because usually I never worked with horizontal bars. Okay, I just found out for horizontal bars we can just use height. So if we have bar h, we can use height 0.2, and yeah, we get the same result for horizontal bars. And yeah, the default value for height is 0.8, so they are a little bit bigger by if you are deciding for 1, except they are that big that there is no gap between our bars. Okay, now let's get back to our usual bars. What we can also do, of course, like in other graphs, we can change the color to, for example, pink. Here we go. And yeah, we can align the bars. Now the name is in the middle, or the names are in the middle. We can put them to the edge, or not with a color. Let's stay pink. And yeah, a line can be put to edge. And yeah, if you want the bar beginning with the name and not in the middle of the bar. Okay, one last thing. Let's do an example. For example, we have our, we have ways like 87, 89, 90 and 91. And yeah, the difference between these bars is pretty low, but we still wanna show the difference clearly, or more clearly. We can say bottom equals 85, and yeah, now, of course in that case we should get the right values. I'm a little bit stupid today. 5 and 6. And yeah, now if you look at the bars, you can see there's a main difference, because John is 78 and Bob is 91. And of course for the values you shouldn't use common values, but the values minus the bottom. And with that in mind, I'm finished for today's videos and lead you to the outtakes, because there were some. And see you, bye bye. Hello ho ho, and welcome to another episode of Python, and welcome back to another episode of Hello whoa, and welcome back to another episode of Python and another one of Hello ho ho, and welcome back to another episode of Hello, welcome back to Python, welcome back to Matplotlib. And today we are looking at histograms. First of all, like always, let's import matplotlib.pyplot as mtp, and again, like always, mtp.show. Now let's create some data. Again, just a list. List t equals 1, 2, 3, 4, 3, 2, 1, 3, 3, 3, 3, 2, 1, 1. Let's add 6, 7, 8. Now let's type in mtp.hist takes listy, and let's run our code. Not this one, this one. As you can see, we created an histogram, and shows us just how much each number occurs. For example, the 1 occurs 3 times, 4 times the 2, 3 much more, and so on. What will happen if we add 200, or let's say 2000 in our data? As you can see, all the small values are summed up to 1 bar, and yeah, the last bar is a 2000, and yeah, between is a large space. That's kind of how histograms work. So he's kind of setting dynamically which stages are chosen. So let's kind of import NumPy. Let's create list t2 equals np point random point normal. Yeah, let's do 160. Standard deviation is 29. No, let's do 30, and yeah, let's do 25 times, and let's do it with list t2. Here we go. Yeah, now we got some random numbers between mainly 160 with some standard deviation, and yeah, here you can see each occurrence, and that's a histogram. So yeah, 250 values between 160. Most of them should be near to 160, and yeah, really kind of helpful if you have wanna compare value and the number of occurrence. For example, if you have some data and want to see any limit points. Now let's explore some of the arguments the hist function has. For example, bins. Let's just type in bin equals 20, and yeah, what happens now? The bars aren't set dynamically anymore. He is now having 20 bars, and yeah, we can even do it like this. Bins also can be an array, for example 0, 20, 30, 80, and 200. Let's see what happens. As you can see now, he created one entire bar for the space between 80 and 200, and of course that's most of the space. Yeah, but most of the times you want each bar with the same size, so you can just type in 30 if we want small dots, and as higher bins are, let's say 200, 100, and let's start. As higher the number of bins are, as more detailed it gets. Yeah, like always, we can change our color. Color equals red, and now everything is red. If we add another color like red and green, by the way, if you have only one color, you can just type in the strings. You don't need a list. But in our case, of course, we need another data set. Let's do it like random point rand n 2, and now we have two different colors. And if we do the same stuff with some standard deviation, we can do something like 160 plus p random, and then it's not the same you have but you know what I mean, I guess. Now we have 160 as a middle point. Because if we are using this, we have 2 dimensions, so we have kind of two-dimensional arrays. Each 160 part elements in an array, and each element is also an array which contains 2 elements. We can also do it like 4, and then we need 4 colors. Let's add black and what else? Blue. We can do it like this, but 160 is a little bit much. Let's do, no, 160 isn't that much, but let's, instead of, yeah, 100, let's do a 21, a 20. This looks a little bit nicer in my opinion. So yeah, here we are seeing each value of the element of the array, and yeah, each element of the array is also an array. So for example, yeah, the array, let's print it, then I can show you. Let's print it in the console. So here you see the last one, for example, is 160, 149, and so on. And yeah, the first one are the red ones, so the second one you can count as the green ones. This one are the, oh no, let me have a look, black ones, and then the blue ones. And yeah, 162 got no blue ones, but one black one, and yeah, I guess 5 or 6 green ones, or 4. Yeah. Now what we can also do, we can, yeah, kind of try another kind of visualization. We can stack them. What do I mean with them? With that, let's type in stacked. Stacked equals true, and let's run our code again. And yeah, now the red, green, black, and blue ones are not next to each other, but yeah, you can see they are stacked up. So yeah, 161 has has 1 red or 2 red or 3 red, I don't know. It's hard to describe or explain it, but it's easy just by looking at it to understand what I mean. Out of our array counts, yeah, 100, with the value of 158 we got, yeah, 1 or 2 in the first column, which are red, then in the second column are green, and so on. If this is too colorful for you, you can just type in fill equals false. Now again, here we go, now it's not filled anymore. We can also say hist type equals step. No. Okay, not hist type, hist type. Now let's see what happens. Now we got the color, so this is a little bit better visualized. So yeah, you should, if you want it unfulfilled or unfilled, you should do it like that. And with that in mind, I'm finished for today. I hope you could learn something. I don't know what is the next topic. I have to think about something. But yeah, apart from that, I wish you a wonderful evening, dinner time, night time, whatever time it is. See you and bye bye. Hello, yeah, welcome back to Python with another video about Python, obviously. Okay, I will, yeah, welcome to the outtakes, I would say. Hello, welcome back to another Python video. Hello, ho, ho, welcome back to Matplotlib, welcome back to Python. Yeah, and today, after looking at many charts and many bars and stuff like that, we are finally heading to pie charts. You probably know the charts, or yeah, graphs that look like a pie, the round ones. If you don't know what I mean, let's simply create one and I will show you. First of all, like always, we need an array. In this case, we need only one array consisting of a 1, a 3, a 5, and again a 1. And yeah, the function, okay, we have to declare it like ax equals np array. And yeah, now let's do the function we need is pi. Argument is our array ax. And yeah, like always, we need to show our stuff. Let me show you. Here we go. On the right, you see our pie chart. Yeah, what happened here? We had our array, And yeah, he chose for each part or each element of our array, he chose a part of the chart. And yeah, he, for example, he took the 1. 1 is 10% of 1 plus 3 plus 5 plus 1, which is obviously 10. And yeah, he made out of 1 out of 10 is 10%. 3 out of 10 is 30%. He uses orange. For the next part, then for the next part he used green, is half of the chart because we are having 5. 5 out of 10 is 50%. And yeah, then we got to the red part. 1 out of 10 is 10%, so 10% of the chart is then red. Okay, pretty simple, but yeah, that's a little bit tiny for a chart. So what can we do next? For example, we can use labels. Labely equals now again a list of 4 labels. Here we go. Pretty uncreative, but yeah, this is just for test courses. So okay, not labely, labels equals labely is pretty much equivalent to the charts and bar, to the matplot bar, I guess. So yeah, now we see he starts with 1, 2, 3, 4. Now we see the direction of the pie chart. 1 is the blue one, and yeah. If we want to start from the other side of the chart, we can say start angle equals 180. Now let's see what happens. Yeah. Now we see 1 starts off the other side of the, you can see it's kind of mirrored because we are the blue part is now on the left side instead of the right side. Now what we can also do, we can use explode, and kind of makes us the pie chart will kind of explode. So what we need for that is another array, x2 equals np point array containing some floats like 1.4, 1.1, 1.1 and 0, not 1.1, 0.1 and 0.4, sorry. And explode equals x2. Now let's run our code. Here we go. You see it's kind of the 1 because the first one was 0.4, the biggest number. So it got most away from the center. So each value of our explode array represents the distance between the center. For example, 1 has the highest value, 0.4, so it has the highest distance from the center. Also pretty simple and pretty easy to do. We can add shadows with shadow, just using a boolean, in this case true. False is the default. Now our pieces have shadows, like they are floating above a white piece of paper. Like always, we can add colors. Let's do that quick because this is kind of similar to the other charts and bars and histograms and stuff like that. Here I created some colors. Now let's see, colors equals colors. Let's run it. Here we go. Pretty simple. Because we made it in our last video, let's add some legends. Yes, just using mtp point legend. One again. Here we go. Now each color has kind of gotten a little description. We already had that in our last video. Smaller radius can be changed by just using a boolean and using the radius argument, like in this case. Now it got pretty smaller. Let's do it. Can even do it like 0.4. Here we go. And if the also add a title to the legend. Title equals point list chart. Here we go. Now what is kind of complicated, but auto percent means in the different parts of our pie chart the percentage is shown. For that we are using our percent sign 1.1, now an F for float, again to percent sign. What does that mean? Let's first look at it. And yeah, of course, let's change the black one to yellow. And let's add some radius. Yeah, much better. Now the percentage 1.1 we can kind of means 1 percentage after our comma. It's a float. If we want a larger number, like 2 2 elements after the point of our floating point number, we just add a 2, and we can expand it to 3, 4, 5, 6, 7, 8, I don't know. Kind of a little bit similar if you are learning C and you are working with printf. You probably know how to do that. In any other case, just remember what I told you. This number is kind of important for the pie charts. Now last but not least, another great tool of visualizing everything, and for that let's just delete our auto percentage, because now we are using hatch. Again, square brackets, and in that we are, so if we want to, I don't know how to describe it, if we want a specific background, a kind of hatch visualization, we can add certain symbols as a string, kind of hatching each slice. For example, we can add an O, this one, and even this one should work. Let's add a new line and let's run it. As you see, looks much different in this case. But kind of awesome for our legend, because in this case, even if we have two blue slices, the slices look kind of individual because of our hatch. And there are many ways to alter the hatch, many references, many patterns. You can Google it, but the possibilities seem to be infinite. And with that in mind, I'm finished for pie charts. And I wish you a wonderful evening, dinner time, night time, whatever time it is in your country. See you in the next part. Bye bye, and have fun with the outtakes. I guess I got some. Then the next one was 3%. He chose orange for that one. Then for 5%, not. You know what? I will do it again. Hello, and welcome back to, oh no, that's too deep. That's better. Hello, and welcome back to Python, welcome back to Matplotlib, and welcome back to, that was too much, welcome back. Hello, whoa, and finally welcome back to Python, and welcome back to Matplotlib. And back to 3D plotting. And got really sick last days, that's why I didn't record anything. Feeling still sick, but needed to do something to kill the time, so let's head to more 3D plotting. And because it's a long time ago, let's repeat the elemental steps of the 3D plotting. First we need plt, not that, plt point figure. We have to declare an object, x equals plt point axis, projection, it's an argument, projection equals 3D, written in lowercase of course. And let's simply say plt point show. let's run it. And yeah, here we go, our 3D, here we get our 3D map. We even know that. And yeah, by declaring, let's say, 2 numpy arrays, I mean 3 numpy arrays, because we have 3 axes. We need, yeah, 3, for a simple graph, we need 3 one-dimensional arrays, numpy arrays, plt point show. Yeah, I had to look up for the function, it was plot 3D, taking at least 3 arguments, which are the axes. And if we run our code, one second. By the way, I got it wrong. It is not plt point plot 3D, it is x point plot 3D. Now if we run, you can see our graph, which is 3-dimensional. Taking a little turn here on, what is it? X like 1.5, 0.5, something like this. It's hard to catch it because it's 3D. But yeah, that's for the reminder. Now let's do something different. Let's create a little surface. For that we are changing the dimension of our numpy array Z, adding, upgrading it to a 2-dimensional array. And the function we are using now is plot surface. And let's run it. And now we got a little surface. We have 3 rectangles, not 3, 2 rectangles. I'm still sick and not able to count properly. But we can create surfaces, and of course more elements of our arrays make them more complex, being even able to kind of simulate certain terrains or even models. So you can think for yourself, what do we need if we want to create a really simple square, for example. You can pause the video and think for yourself. I'm doing one, if I can remind it correctly. Because as a quick reminder, if you're confused, we get, these are coordinates, 1, 2, 0, 2, 1, 1, and so on. So for example, if we have 0, 0, 1, 1, let's do only, let's do less elements, and let's run it. We got our square. But square is boring. Let's create a rectangle, or let's create a object in the shape of a rectangle, of a roof of a house. A rectangle, roof of a house. And you should always delete this. Oh no, you should delete this commas anyway. But let's add another element for each of our arrays. Now we already had 0, 0, 1, 1. Let's have 0, 1. And our z-axis containing only zeros and ones, and this is a float. We wanted 2 elements, not a float. Here we go. We already have 2 of them. So let's add another one. And again, you can think for yourself which coordinates are needed for the third part. We want to create here a rectangle, like it's already another line from 0 here to 1. No, from 1 here to 0. I hope you get what I mean. Pause the video and let's do it now. It's pretty simple. Just another 0. Because he needs to draw back to our 0, 0 coordinate. And for that, just another 0. here we go, we have our little roof. And yeah, you can create a lot of objects, but yeah, can be quite fun to experiment with it. And yeah, you can spinning, could even do art contests with it. Depends on you, but yeah. So let's move on. Of course we can do kind of messed up stuff with that again. And p point random point rand gets us an array with 100 floating point numbers from 0 to 1, if I remember correctly. P point array. Let's do it. Oh, I'm totally stupid. I mean, and p point rand. Yeah, for the shape, let's do it like this. Yeah, kind of really messed up, looking like collection of shards, because we have 100 different coordinates. So let's do something like sorted. Let's try out what will happen now. This is, yeah, you can try different functions, of course, because he's kind of sorting each one. The output looks a little bit what means I wanted to say more structured, but yeah, this doesn't look structured, but yeah, you have to be honest, it looks slightly different. Now that still looks a little bit boring, so let's try something else, because you can do pretty fun stuff regarding color. So let's change the coloration a little bit. We are doing that with the cmap argument. cmap equals, now we use plt point get cmap hot. And yeah, you can even think for yourself, the output is now consisting of colors from yellow, red to kind of black. Yeah, and orange, of course, which is between yellow and red. Kind of reading the surface. And surfaces that are more on the top got yellow. Here you can see surfaces that are mostly on the bottom got black. But yeah, let's unsort them, because got kind of, in that case I guess it looks a little bit more interesting if we don't use here we can see it even better. The ones which are more at the bottom are got blacker, and on the top it gets hotter. If you want, you can also, if I remember correctly, you can also add 2 dimensions to the x-axis. Doesn't change that much, but now they have to be also linked with the 2 dimensions of the x-axis. Same goes for the y-axis. 1 second. Here we go. Let's return. But in my opinion, just looks overloaded. But there are many cases where this can be useful. But looks a little bit too overloaded in my opinion. But like I'm repeating myself, kind of know a few scenarios where this can be helpful. And already hit the 12-minute mark, or no, 11-minute mark, but regardless, let's say goodbye, see you in the next video, have a nice evening, dinner time, night time, whatever time it is in your country, and I don't have any outtakes today, I'm sorry. See you and bye bye. Hello, welcome back to Matplotlib and welcome back to Python. Today we are looking again at bar charts. I mean the bars we got in our third video, I don't know. And we wanna do back-to-back bar charts, a variation of our bar charts. But of course, because it's been a while, I will repeat a little bit regarding bar charts. So first of all, we imported NumPy and Matplotlib. Let's create two NumPy arrays. We wanna name it 1, 2, 3, 4, 5. And array 2. This is the height of our bars. The first one is a kind of position of our bars. 1, 6, 8, 9, 0. Should be the same shape. Now, as a reminder, we used bar as a method. Input first was is the first array because the positions and then the height or the value. And of course we need plt point show. Okay, and here we go. Of course, because number 5 has the value of 0, there is no bar. But this is pretty obvious. And you can, like always, you can alter your chart regarding colors, labels, percentage, all stuff like that. You can even add a legend, but that's not what we are looking today. Today we are looking at the same, but back to back. So what does it mean? We kind of wanna create a second bar, and we can of course use again the bar function, do it again like this, array 2, and run our code. And as you can see, it just got red, but nothing interesting. So what we can do is pretty simple. We can use a minus array. Each value will get minus. Or we can, let's do it in a simple way first. Let's do minus, so each value will get negative. Run it. Okay, because we in that case we of course need NumPy arrays. Don't create just lists. It's much easier to work with NumPy arrays. In that case I forget it, but you shouldn't. Don't do my mistakes, learn from my mistakes. Okay, let's run it. And here we go. Pretty simple. It's kind of mirrored in a strange way because they are the same values but negative. So let's change it. And of course we can even add another array. Let's do array 3 equals NumPy array, not append, array -1, -2, -7, -3, and -1. Let's change it to array 3. And again, here we go. That's exactly what I meant. We can do the same but horizontal by adding an h. So it's of course it's another function. You can see it's bar h for bar horizontal. Here we go. And that's probably it. Pretty short topic for today, but kind of served as a reminder of bar charts, added some new stuff, and kind of a filler because I'm preparing a much more complex video which is just 3D plotting, but can be much more confusing, so this shall serve as a little gap between those topics. See you, and wish you a wonderful evening, dinner time, night time, whatever time it is in your country. See you and bye bye. Hello and yeah, welcome back to Matplotlib and welcome back to Python with another part of Matplotlib obviously. And yeah, today we are looking at 3D plots finally heading, or what means finally heading. We already head into more advanced territory, but yeah, now it will get even more complex, but yeah. If you got the last videos pretty good, this shouldn't be a problem either. And yeah, you can do much more complex stuff with Matplotlib. Stuff that will blow your mind. So yeah, we are starting pretty simple, pretty easy. And yeah, function we need is plt point figure without any arguments. Yeah, figure can be pretty anything. Figure is, by the way, a function. As I first thought, I thought it was an object or a class, but no, it's a function. Because in this way we are kind of working more with a figure. What happens if we already press on plt point show? Nothing, because there aren't any axes. So let's create axes, because we need a three-dimensional coordinate system. So yeah, x equals plt point axis and projection equals, and now we need a string as an argument, which is just 3D, kind of a magic keyword. And here we go. Now I got a figure. I got a three-dimensional coordinate system, which shows us coordinates from 0 to 1.0 in 0.2 steps. And yeah, kind of cool. We can spin it a little bit if we are bored, but yeah, that's not what our goal is for today, even it is much fun if you're really bored. So if we wanna plot or add a, for example, a linear function or just a graph, we use x, as we use our object we created here, and say x point plot, and then 3D. Now we need not 2 but 3 arrays, and p point array 1, 2, and p point array 3, 2, and p point array 1, 3. Now let's see what happens. I guess I made too much brackets. Oh no, I forgot one here. And here is, and this is not a numPoint array. NumPoint, I mean NumPy array. And here a bracket is missing. Okay, don't look at the mess I created here, just ignore it. And this should do it. Let's try it out. Here we get our first graph, our first two-dimensional graph. Pretty simple, but this is just the beginning. Kind of obvious. We can can create a new dot, which is which we can link like that. And if we kind of want to create an Eldritch abomination, we can use np.random.rand. Let's do 10. Here we go. Not Eldritch enough. Let's look at more Eldritch. Here we go, that's what I wanted to see. This is an Eldritch abomination. Can even, like always, I don't know if I need to tell you, but we can choose our color. We can do it in green. And the same should work for scatter. Let's do scatter. So now we created three-dimensional dots here. And yeah, where am I? Ah, here we go. Yeah. No, I mean that. Oh, sorry. 1 second. Yeah. We can do the same for scatter. And yeah, this is, I wanted to start pretty simple because next time we create yeah, our own surface. So yeah, we are getting even 3-dimensional in case of our plot. And for that, I wish you a wonderful evening, dinner time, night time, whatever time it is in your country. And yeah. Next video will be a little bit more confusing. It's a long time since I did that, or not a long time, but I need to, yeah, kind of rethink it for myself. Yeah. But enough for today. See you in the next video. Bye bye. And I guess I don't got any outtakes today. Bye bye. Hello, whoa. Yeah, welcome to another episode of Python and another episode of Matplotlib. And yeah, we are back to 3D plotting. Today with a more simpler topic than the last one. Many things are just, yeah, kind of reminder, but yeah, we are back to scattering and back to, yeah, we are scattering, but now in 3D. So yeah, let's keep those variables. I use kind of the same code as last one, but we are not doing plot surface. We are still using plt point figure and x equals plt point axis, but now we are using x point scatter 3D. Yeah, using 3 variables as an input. And let's just run it. Here we go, and we got a dot at position 111 here. Okay, yeah. Like always, kind of hard to find the dot, but here we have a dot. Okay, but this is pretty boring, so let's, yeah. We have our NumPy array. Let's try it out. Let's do x, y, z. Let's do it with our NumPy arrays. Yeah, as a quick reminder, here we get arrays containing, yeah, random floating point numbers from 0 to 1. Let's do it, and yeah, here we go. Now we scattered a lot of random, yeah, dots. Pretty simple, pretty easy, pretty self-explaining. So of course we can have an array of integers, so can use rand integer, low, high, and yeah, size equals 100. Now let's check. Okay, and of course I guess the issue here is that we got, yeah, different D types. So if we are using it like this, it works, yeah. Because yeah, he has floating one variable with floating point numbers, one array, and the y and z array contained, contained floating point numbers, and the x array contained integer numbers. So you have, yeah, the D type of each axis has to match. But now we can do stuff like, yeah, we can decrease the lower one like this. And yeah, looks the same because he's just altering the look of the axis. But yeah, let's just add 99. And yeah, let's do x point append. This should work. Append. Yeah, but because we're NumPy, we have to use it like this. And p point append. Like, yeah, 99 is the value. Let's do it. Let's try it. kind of having a numpy. Now we got it. So yeah, what I wanted, I wanted to put all the dots on one axis, and yeah, I was adding one dot which is in a kind of different place. We get most of the dots at the ground or at the wall, and yeah, that's how you can do it. So we can do, like always, different markers. Marker equals, let's do star, using an asterisk. Also possible, now you can see, let me do it a little bit larger. Here you can see we got asterisks, and yeah, we can also of course change the color. Color equals red. Now we got red little asterisks, and yeah, we can add another one. I will do it now like a total noob, but yeah. Let's do it like this. 10, 20, and yeah, color is now green. Let's run again. Should work. Yeah, it works. Now we got green. We got a kind of green one, or a portion of green ones, green stars above the red stars. Yeah, can do it again. Just make sure the range of the new numpy array is between new values. So now we can add, tell me a cool color blue, and let's do little shapes. With S is for shapes, and you can just Google what different markers are existing. Now we got little shapes above the green stars. And yeah, now let's mix in. What do we do? What do we want now? Let's do from 0 to 40. Size, let's do 399. And of course here it has to be 400. And yeah, scatter after shapes, so let's do let's do triangles. Oh. Yeah, of course not yellow. Of course not blue. I wanted yellow ones. Here we go. Now, yeah, there are a lot of yellow ones between them. Oh, I'm totally stupid. I have to do it like this. And yeah, now triangle and yellow. Here we go. Why doesn't it work? I want to add yellow triangles. Why doesn't he do that? Oh, I guess I missed PLT point show. Yeah, I missed PLT point show. Okay, now here we go. It looks like a lasagna with some eldritch ingredients. Yeah. And for that, yeah, let's have a closer look at our little lasagna. Here we go. I guess if you try this lasagna, you will instantly turn into some, yeah, eldritch abomination. And with that in mind, I wish you a wonderful evening, dinner time, night time, whatever time it is in your country. See you and bye bye. And I have to find the button to end this video. I mean, this is kind of a masterpiece of its own, so you should see the full extent. And we dive deeper. Hello ho ho, and yeah, welcome back to Matplotlib, welcome back to Python. And yeah, today I don't really know if this is a final video regarding Matplotlib. It's a long time I made a video, had much to study, much work around, so yeah, I guess I'm back. Can't really tell if I can upload videos in a short frequency, but yeah, I try my best. And yeah, next topic is how to animate stuff. We already plotted, made wireframes, made certain types of diagrams, and now we want to animate stuff. And yeah, we don't really create animations like you animate, for example, a dog or yeah, an image. Instead, we are trying to find new ways to animate our graphs, our diagrams, automatically update them automatically. And yeah, next video will maybe be a little project, so yeah, let's start. Yeah, in our last video we made a wireframe. Let me show it for you. Here we go, this is a little wireframe, and yeah, what we want to do, we want to alter this wireframe, and first of all we want to add another wireframe. So we created certain arrays which are filled with alternate versions of the get tested data dates, which is a variety of data we can simply get by using this function, which can which is kind of serving as our X, Y, and Z axis. And yeah, we want to plot two different, we want to plot two different wireframes. Again, if we are asking what am I doing here, we made a 3D wireframe, which is kind of simulating a surface. And yeah, now if we just run our script, we have two different wireframes, and it's kind of easy to tell which wireframe is what. So yeah, let's run it again with a different color, like this. Now we have a red wireframe and a green wireframe. Here you go. And yeah, the function we are kind of looking at today is the pause function, and it obviously does what it looks like, because if we type in pyplot.pause and using a double as an input, he will pause for 100 milliseconds. Yeah, pretty fast, so let's upgrade it to 1 second. Yeah, you see for 1 second there was only the red wireframe, and now we added the green one. And what we can do for I in range, let's say 10. Can say pause again. Can add our array into our loop. So we have a loop creating or altering our Y, X, and Z data every time we are kind of refreshing our data, because we are declaring our data in the loop, and we are pausing at 1 second. And let's do something like, let's import random for that. We don't need the NumPy random for that. Let's use the regular random library, random point choice. Green, red, yellow. Let's do a black. And what can we do? Orange, I like orange, and blue. Now let's run our script. Okay, first one, second one, third one, fourth one. Yeah. As you can see, he added then 10 different frames. Can zoom in. Looks kind of even more like an Eldritch Abomination. Yeah, 1 second. Let me show you. I mean, this is kind of a masterpiece of its own, so you should see the full extent. And we dive deeper and 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 deeper. Okay, yeah. So again, okay, so what we're gonna do next, we declare our wireframe as a variable, or equals, let's say our wireplot VP. So we still plot our, we still create our wireframe, place it in our system, in our coordinate system, animate it, and create it. But we're also declaring a variable, and now we can remove our variable with v.remove. And vp equals our new variable. It's important that we also declare a new variable, because at least in our second loop he will give us an error because there's nothing left to remove. So here we go. Now he will choose a random color and random coordinates like he's supposed to do, and 10 times. And because we want to do it infinitely, let's do a while truth loop. Let's run it again. And now we will do it infinitely. Or not. Maybe not. Okay, I thought he will do it over and over again, but he won't. Don't know why. By the way, I should the frame should be a little bit smaller, like this. Let me see what could be wrong here. And I'm just retarded. I forgot to do a while loop instead of a for loop. So let's do it again. Now he does it in a loop. Can see. This is kind of cool in my opinion. Still, as a little side effect, the coordinates will get smaller, or the figure itself will get smaller each time, but it will take much time until we are until the system gets significantly small. So but we are already at 200. At some time we will be at 400, but I mean the y-axis you can see here where I'm at my cursor. Now he will always get higher and higher, but I think that's not now that much of a problem. And we can do this with any kind of data. I guess next time I will do some other frames, other kind of objects. I will do it with bars, lines, anything like that. We can, you can be creative. You can try it with different. things, you just have to use this kind of code. There are many other functions, many other ways how to solve it, that it will, update itself infinitely. And I'm thinking about a project where you can just access data from, for example, using an API, and getting this data by using that API and updating your own frame. There are many possible ways. Next time we will have a little bit fun, I guess, with scatter and bars and stuff like this. Until that, see you. I wish you a wonderful evening, dinner time, night time, whatever time it is in your country. And I hope you had fun while watching this video. I have nothing more to say, but I hope you had wonderful Christmas time, wonderful New Year, and see you. Hello ho ho, welcome back to Python, welcome back to Matplotlib, and welcome back while we are trying to animate our plots, scatters and everything else we created in our previous videos. So now we are looking at how to animate the scatter function, or while animate the scattering process, however you wanna call it. And we have our code from our previous video here, and so what we're gonna do is we wanna scatter. So let's just use pyplot.scatter, one y and one y axis. Let's run. And this was old code. I just tested something. We are at squabby wabby. So let's run subby wabby. One dot because we scattered something. This was just as a quick reminder how to scatter. And now let's scatter some for e in range 10. Let's do 100. Pyplot, no. Let's just scatter some stuff. This is all as a reminder, so random point went int, let's say 1 to 100. Again. Let's now run it again. Now we have 100 little dots. And cool thing, because we don't scatter an array, but entirely different dots. Each dot will have its own color. Of course, we can set the color to a certain value, but in this case, it looks like little dots. So it's pretty simple. Because again, we need pyplot.parse and do it again like this. And now he will scatter something, or scatter our dots. And depending on our highest and lowest value of each dot, he will kind of alter the coordinates, but it shouldn't get higher as 100 on the y and x axis. And he's already finished, I guess. So let's do it in an endless loop. Let's do a while true loop. While true, no. Pretty late, to be honest. Just recording at 11 p.m. or 11:30 p.m. and I have to get up tomorrow in about 7 hours. But here this goes at an endless loop. It's pretty much the same as last time when we had to animate our wireframe. Now we can remove those brackets, I mean. This goes endlessly. Guess if let me see something. When I kind of when I kind of close a frame, it won't get any further, or it will kind of save what the current state and will add every dot. Did I reopened it? Yeah. But here you can see it goes endlessly. Yes. So now let's do something more interesting. Let's import datetime, and yeah. Let's do something like this. And now we have seconds. So let's do a second. I just created second equals datetime point time point second. So it should give me the second, the moment. Or let's test it, because it's long ago since I did something like this. So let's just print it. Okay, 1 second. Why I have to restart it. So yeah, okay. I don't know, can you see it on the... No, you won't see it because I minimized it. Here you can now see it. I will just get the object. So yeah, that's not what was intended. 1 second, I will pause the video until I solve the issue. Okay, I solved it. Totally simple, but yeah, I simply forgot it. You don't say import datetime, or you don't write import datetime. You write kind of from what kind of, you totally 100% should do it like this. From datetime, import datetime. Datetime, yeah. Okay, and yeah, now we can write second equals datetime point now point second. So, and now what we're gonna do, we wanna say, yeah, A equals second, B equals second plus random point randint. Let's say 0 and 10. And now let's see what will happen. Yeah, as you can see, he is kind of moving to the right. Yeah, for each second that passes. You have to, yeah, calculate minus 10, because now we should between second 30 and 20. Because, yeah, he's placing the dots between 30 and 40. Yeah, let's do it a little bit quicker. Stop. And yeah, let's say, let's do it quicker, and let's say 1 second. Let's do it like this, first second. So our x-axis is second, and yeah, let's say random point randint between 0 and 100. Yeah, as you can see, now he is placing the dots in a more, how do we want to call it, more linear way. Yeah, let's say it's a more linear way, more sorted way. Okay, now he started from 0, and he's moving in the middle, because the second we started was about 42. It was 42. Perfect. Okay, let's do it even quicker than that. Pause it, minimize. Okay. And let's do between 10. Okay, he isn't, he can't, I guess, calculate it. But yeah, that's it. If we want more dots per y-axis, we can simply do something like this. Yeah, now he will stay a little bit longer. Should be about 2 seconds. If I'm not stupid, maybe I am. Yes. Okay. I just wanted to search for my script for the 3D one, but yeah, we are a little bit over time. If I would do the 3D one, we would get the video would get a little bit long. So yeah, let's stick to this one. I guess it was interesting enough. So yeah, be creative. Maybe you can use an API or you can animate stuff based on your own creativity. And yeah, apart from that, I wish you a wonderful evening, dinner time, night time, whatever time it is in your country. And I hope the recording wasn't too quiet. See you in the next video. Please leave a comment regarding any critique, anything I can improve. And yeah, is there anything left I could tell you? Not really. So yeah, see you, bye bye and goodbye. Hello ho ho! Yeah, welcome back to Python and welcome back to Matplotlib and yay, no. Hello, yeah, before we start our video, I just wanted to warn you regarding flashing lights because yeah, this could trigger epilepsy, and yeah, you should be warned. Flashing lights will occur, but yeah, if you're scared of them, just skip this video. It is kind of self-explaining if you already know how to plot bars and yeah, watched my last videos. You will probably know how to animate bars. I will give you just a few examples in this video. But yeah, if you won't be triggered by such things, I wish you... Okay, wish you is the wrong word. I hope you enjoy the video and yeah, see you. Hello, ho ho, and yeah, welcome back to Python, welcome back to Matplotlib. And yeah, today we wanna again animate something. We want to animate bars in Matplotlib, so yeah. And for that, let's first create our bar. First of all, let's import numpy as np and let's import matplotlib as plt. I mean matplotlib.pyplot. And yeah, plt.bar. First of all, we get our labels like A, B, C. For our bar, then we have our values like 1, 3, 4, and we have our width, so how wide the bars are. And with plt.show we already have our bar chart. Let's try it. And yeah, of course, without the
brackets. Yeah, here we go. Pretty simple, and yeah, it's too big. Let me put on the right side. Here we can see our bars. Yeah, pretty easy, but we wanna animate them. So yeah, how can we do that? Let's create something really simple I created before. First of all, we need our while true loop. While true. We don't need plt point show because we are using our function plt point pause. This one 10 milliseconds, and yeah, won't do much in this case. So let's name our bar like bar equals plt point bar, and yes, bar point remove, because but let's remove our bar after the pause. So bar point remove. Okay, but based on the fact that there won't happen anything, let's random point random. Yeah, with import random. Can also use numpy point random, but yeah, depends on you what you favor. I guess numpy should be faster because it's based on C code. But nonetheless, this should work for our little experiment. So let's start it. Yeah, here we go. Oh, really flashy, but yeah. Let's increase the size. Let's close it. And yeah, let's do it in a slightly smaller way that's not so flashy. Yeah, we kind of animated it. We animated the width, and the color is also changing because we didn't choose a specific color. Now what we can do next, we can choose also our values can be chosen by random point rand int 0.10 between 0 and 10. Oh no, let's say between 0 and 30 and 0 and 30. Now if we wanted, yeah, you can make useful stuff with Matplotlib, but you can also do things like me, like always playing with stuff. But yeah, for that, why should we do that? We can kind of update our bar charts depending on an MPI, depending on information that is given in a certain order or in a certain time, on certain timestamps, so we can update our little pie chart, our bar plot. You probably know what I mean. Yeah. Okay, next step. Can even go further. Let's do 1 second and do something like var1, which means values 1 equals a for a in, let's import a string. Or was it string? Yeah, it was string. For a in string point ASCII letters, and 1 equals random point rand int, let's say 1 to 30 again, for a in range for 1, length of for 1. course, this has to be value 2. Now we can simply say value 1, and yeah, the have, I don't really know how to pronounce it. And I missed something. Yeah, we don't need that anymore. Okay, let's try. I wonder what will happen. Yeah. As I expected, kind of have randomly chosen graphs. Okay. What else can we do? Of course, we can vary our the length of our or how many bars we wanna plot. We can also choose this by random if random point rand int zero one. Now the bars are, the length of the bars are chosen randomly. The letters are chosen randomly. But once plotted, he won't delete anything. Okay. What we also can do, let me first explain what I did here, because I coded much but didn't explain much. So yeah, we have value 1. We have, first of all, we have to use our values, which represent the labels. You can see here A, B, C, D, E, F, G and stuff like that. And because of that, we used list comprehensions and said A for A in string point ASCII letters, or ASCII letters, it means if random integer 0, 1. So yeah, an integer is always true if he is not 0, and he is always false if he is 0. I don't know if the numbers are negative if he is also false, but yeah, integer 1 is always true and integer 0 is always false. So I just decided that the string should only be added to our labels if random rand int is equals 1. So he's generating an integer between 0 and 1, and the chance that it will be added is 50-50. And then we create our values of each bar, which is between 0 and 30. It is for A in range a length of value 1, because we want only as much values as much as we have our possible labels. And then we are plotting our bars with random width, and then we pause 1 second, and after that we remove. Maybe you are asking yourself what will happen if we remove them. He will just kind of overwrite them, as you can see here. Because many plots do have the same label, so he is adding them to the same label. So last but not least, we want to create kind of a label that, or a bar plot that updates itself every time, but which won't delete the last ones. So for example, we have 2 bars, then we add a third bar, which will be added on the right. Then another one will be added on the 4th place, and it will get smaller each time, or the width. This one here will get smaller each time. You probably know what I'm talking about. So let's do it really simple. Let's say our first label is 1, a equals 0, and let's do our first value equals f a. And yeah, now we can also use our values operator like this. But let me think, I guess this is not possible if we are formatting strings. Wrong direction. No, I guess this won't work because we are formatting something. But yeah, let's do it the simple way. Let's just say format A. A will get added by 1. This will also be a random integer, like always. And we are using for 1. Yeah, let me look what happens now. Yeah, you can see it now. It will update itself. And yeah, that's why you can use animate, because you can update your own chart, your own plot, your own bar like this. Yeah, this will now does its thing endlessly. It's kind of, we are in an infinite loop, so he will randomly add simple charts, simple bars in that case. Yes. But yeah, with that in mind, I'm finished for today. I hope you had learned something, had fun watching this video, and see you in the next video. Wish you a wonderful evening, dinner time, night time, whatever time it is in your country. And yeah, bye bye. Anything else I wanted to say? Oh, 1 second. You probably see it better if I do it like this. That you don't need to zoom in. Okay, he's already, I don't know which number he already has. Okay, bye bye. Hello ho ho, welcome back to Matplotlib, welcome back to Python, and welcome back to the last part of the animate series. It's a Matplotlib series, but yeah, we have kind of the animate series inside the Matplotlib series. And yeah, this is the last part where I animate stuff. So if you don't like the animate stuff, you can be happy because this is the last one. Yeah, nonetheless, let's dive into, because pie charts are still missing. And yeah, will be a rather short video. Let's dive in. First, as a quick reminder how pie charts work. As always, import Matplotlib, import NumPy as NP and Matplotlib as MLPLT. And of course it is pyplot. I always miss this one. Pyplot. And yeah, PLT point show only as a quick reminder, because we are using pause again. And now, yeah, let's do a little pie chart like this. Let's create a NumPy array, NP point random. Let's do some rand integer. As a reminder, if you want rand integers, you can say low, high, and what was the last one? Yeah, the size. But you have to name the argument size, like let's say 5. And now if we say plt point pi, and as an argument we are, yeah, using the NumPy array and click on animate series, you should be able to spot on the right side now our little pie chart with random values. If we run again, the values should be different and the colors also, I guess. And now what we're gonna do next is we want to animate it by using our while true loop. While true, which means it is an endless loop, and plt point pause. 1 second as an argument. We don't need plt point show anymore, as you can see here. Now he is changing the values by random. And so if you don't want that he is also changing the colors, let's close it. You need, like we already handled it in our tutorial regarding pie charts, black, or let's say green, blue, red, and yellow. And now he would raise an exception. We need a fifth color, like I guess light green. Oh, I got explode. Of course, we need to name our argument with colors. Now he's staying with the same colors. Perfect. Make it a little bit smaller and move it to the right. Okay. If we want to animate stuff, we can also build a little clock with our pie charts. For that, we just need an NP array. Let's say 0 and 444. And we only need 2 colors. Okay, 0 is a little bit, it's not enough. Let's say, let's say black and white. And let's say pause 0.01. And with that, nothing interesting will happen, just based on the fact that nothing during the loop will change. So we have to change something, and this is the ankle. Start ankle equals, and now we are changing the kind of loop. We make a for I in range, let's say 360. And start angle equals I. And now we got a little clock. I can enlarge it so that you can see it better. Or not a clock, more like a moving one. But we can use it as a clock. Now let's make it a little bit quicker. This should be possible. Now let's start it again. It got faster. So what is also possible is we can change something like the radius. Can say let's import random for this. You should do it in numpy random, but for this thing let's do random point random. Should give us a float, yes. And now this kind of funny thing happens. If you want, it's pretty easily. You can use your labels and label everything by yourself. And then you can make a clock. You can make different clocks with subplots, one for seconds, one for minutes, one for hours, and one for the day. I don't know, you can do 5 or 4 subplots with that. There are many possibilities. And just wanted to cover pie charts as the last one. Pretty short video compared to the last ones. See you in the next video, hopefully. Wish you a wonderful evening, dinner time, whatever time it is in your country. See you and bye-bye. Hello, ho, ho. Yeah, someone is writing me on WhatsApp. Hello, and yeah, welcome back to another Matplotlib and Python tutorial, and I don't like the settings. Hello, is everything set? No, the microphone is too far away. Hello, ho, ho, welcome back to Matplotlib, welcome back to Python, and yeah. Hello, ho, ho, and yeah, welcome back to Python, welcome back to Matplotlib, welcome back to, yeah, another video, and yeah, we are back to images and altering images, and so how do we draw a line? That's pretty simple, we already knew how to plot, so let's simply plot something like, yeah, plt point plot. Let's say something like 222, 323, and let's say something like color equals red. Now if we run our little program, you should see it now. If we run it, we don't see anything. That's simply based on the fact that the line is pretty thin. So let's add something like line width. Or first let us add coordinates, because here's the x-axis. Let's add another coordinate like, let's say 0, and on the y-axis we have something like 500, and now again let's run our little program here. And now we got it. We got the red line. Yeah, because we didn't see anything. Now I realized, because we didn't use any markers. But yeah, we can also plot only one coordinate, and we can do it like with marker equals something like x. And now, now you probably see the x. Yeah, this is the code. You probably see the x. And that's also, you can scatter like this. You can also use, I guess, a regular scatter like plt point scatter. And 200, 200. And marker equals like, v. V, yes, it should be V. Now again, yes, again. Okay. Oh yeah, it is blue. You probably won't see it. Let me show you. Let's zoom in. Here, maybe you see it now. Now you should be able to see it. This blue dot here. Okay. So, if we want to add something like a patch, which means a rectangle, or a circle should also be possible, we use import matplotlib point patches as Pete. Yeah, we call it Pete. Why do we call it Pete? Because I like the name Pete. Okay, so Pete point. Let's do something like a rectangle. And the first of all, let's use as an argument the coordinates using a tuple. Like, let's say 400, 400. And next step are the, length and width. Let's say 100, 100. Now let's also say color. Is CMap possible? No, but color is possible. So let's do color. Let's do something like black. Let's draw it. And you don't see that. Maybe it's because we have to add some line width. So let's do that. Let's add, okay. So you see that you see nothing. Okay. Line width equals, let's say 20. again, let's run it. Okay, so we need to add a color. Let's add, okay, you see there's nothing changed. Let's add some color. Let's add face color. Oh no, edge color equals red. Or let's say black. Okay, maybe I do something wrong. And that's for the simple fact that I forgot a function. We simply need to do, let's delete all this, color black, let's have color black. And let's say something like, let's say, figure and axis equals, now let's do PLT point. PLT point is subplots. We only use one, but now we got an axis and a figure, so we can do something like axis point at patch. And now we can add our rectangle, but we need to declare variable ptrec equals axis add patch ptrec. So now it should work. Yeah, it works. Here you see the black. Now, sorry, it was a little bit, I was on the wrong side. And but we finally got our little rectangle. Now what we also can do is, now let's change the edge color. Edge color equals red. And for that we also need to, edge color, I typed in edge color equals black, red. Now we have to switch, like, I guess we raised an exception because he doesn't like the combination of the arguments edge color and color. Here we go. Now he added a red edge color. The face color is default, so let's change the face color. This face color equals white. Here we go. You see it? And you probably even saw that we have other kind of shapes, like a circle. And again, y and x is a tuple, like, let's again say 400, 400. Then we have a radius, and by default it is 5. So even if we just type in the coordinates, it should do something. But it doesn't, so let's add a radius, like radius equals 300. Now let's run it again. Here we go. Perfect. Now we have a radius, and you can also, like in the rectangle, you should be able to change the edge color, face color, and everything is now similar, but we now have the radius. Wait, was I just too blind? Let me run it again without the argument. Can you see a circle? Am I blind? No, there's no. Oh, now I see the circle. Do you see it? Zoom, zoom. Here we go. Okay. Really small one. Okay. And there are other shapes you can try for yourself. And with that in mind, I'm finished. The concept is pretty simple. You have something you can do plot, you can do the stuff. Hello, ho, ho, and welcome back to Matplotlib, welcome back to Python, and with another episode of, you won't believe it, Matplotlib. And after doing some 3D plotting and doing some, animating any kind of plot or graph or bar or whatever you want, now we are looking at images, how to manipulate images, how to show images, how to, alter images and all stuff like that. And This can also be done with Matplotlib, so import Matplotlib. Now something is wrong with the matplotlib.pyplot, like always, as plt. Now import, what do we want to do? Matplotlib.image as img. Today's video will be pretty short because I just want to cover how to load an image. Maybe the first things you can do with that image, like resizing it, or yeah, some modes you can do with it. But yeah, most of the stuff will be shown in the next videos. And we have this beautiful lady, this beautiful pictures generated by an AI. Yeah, because I don't want to get in any troubles regarding copyright. So yeah, we made an AI picture. I can't remember what plot I did used. I mean the plot to generate the picture. And yeah, back to coding. Now what we need is img or image, however you want to call it, image read. And as an input, we have the image file as a JPEG. Now we need to declare a variable because image read returns an object. So yeah, let's call it imagination. Yeah, imagination is cool. And yeah, if we run our script now, nothing should happen. Yeah, finished with exit code 0, nothing happened. Just because we didn't show it, we just loaded it and yeah, saved a variable. Now we need something like, or maybe exactly, plt.imshow. Now the image object like imagination, and even now if we run it, it won't do a thing because we need to, again, like always, write in plt.show. For the case that you've forgotten it, I always forget it, and I also often forget the brackets, but yeah, in this case we don't forget it. And here we go, let me load it. Here we go, we have our beautiful lady. I guess it's a lady. And yeah, we have an x-axis, we have a y-axis, we even now the size, height and width of the picture because it's in the coordinate system, should be around 1024 or something like that. Yeah, now we put that aside. And what can we do with that information? So yeah, now we know how to load the image. We can do something like resize it, like yeah, no, something like this. So if we do this, and let's do it again, not much changed, but the image increased in width because we altered our width because we forgot commas. So let's do it again. Yeah, now we recolored the image. And yeah, let me show you. We recolored the image to a blue type because yeah, first parameter is where to cut the image. For example, we can do something like 0, 0, then it won't be resized, and then where to end. Something like we will test immediately, but let me show you with what is important is the third one, because here we decide a mode. The picture is modified, like if we do 1, yeah, it looks pretty the same, and if we do a 0, now it should look different. Yeah, kind of has a greenish tone now, depends on what colors the picture is already in. If you are more in, if you are more into graphical stuff, you should probably know what the mode means. I have to admit I don't know it. I'm more into the plotting stuff. Yeah, but we can also increase or decrease the size. Now let's put that aside again. And let's do something like, yeah, 0, 0 and 10,000, 10,000. Now, if we do this, nothing would change because, yeah, we start from coordinates 0, 0. Okay, let's first rerun it. Or, yeah, now I did something wrong because we got an empty one. Okay, now I got it. Yeah, it's kind of complicated. I don't use that. I didn't use that before, to be honest, but now I got it. It's pretty simple. You kind of slice slice the image like you slice a list. For example, you can first value is for the height. You can start from the bottom with 0 and go to 1000. Next one is the width. You can start from 0 and go from 1000, and this should give us nearly the entire image. Yes, this is it. So yeah, here we go, 0 to 1000 and 0 to 1000. I guess I just made it impossible to read. Here we go. And yeah, now if the height should only be 100, if we only want one short image, we get it. He will start from 0 to 100. If we want the bottom, we can start from 900 to, let's say, 1000. Now if we start it again, here we go. Now it is, it should be the bottom of the picture. We can check this by just getting back to the original sized image. Like in this case, this looks like the bottom. And yes, let's now try to get the face. This should be pretty simple. We are using coordinates, let's say 200. Or am I right? Yeah. Let's say 200, from 200 to 350. And let's say 300 to 700. Okay, let's try it again. Yes, here we go. Here we got the face. Okay, now if we use a colon here, he should go to default value. Yeah, here we go. Now we have the face. Okay, maybe on some occasions you maybe didn't see what I meant, but for that I will add some watermarks. And I hope you still couldn't get what I was trying to tell. I wish you a wonderful evening, dinner time, night time, whatever time it is in your country. See you and bye bye. Hello, ho, ho. And welcome back to Python and welcome back to Matplotlib. And we are back to images. And this is the code from our previous video. And maybe you can, if you are new, you can just copy it. This simple code will, is able to plot an image. I will show you, and this should be deleted. Okay, 1 second, 2 seconds, 4 seconds. Okay, I need even more seconds. Here we go. This beautiful lady was a kind of test subject of our previous video. And now we are kind of adding some contrast using a CMap. And let's do that. And we are also looking at the interpolation argument. But for now, let's close it and let's do CMap. So if we type in something like CMap equals hot, and this is a valid argument for CMap because it needs contrast map, and I guess it needs color map or contrast map. Okay, I just looked it up. It is color map. Okay, so CMap stands for color map, and we would now have the color map hot. But as you can simply see by comparison, nothing has changed. So this is a changed one and this is the original one. Again, the changed one. Yeah, I see no difference, and to add some difference we should add contrast, and for that we kind of use this slicing we learned in our previous video, and with zero we are adding something which is called pseudo color. And now let's run it again. Yeah, here we go. Now we have, it looks completely different in hot colors. And yeah, CMap has many different string arguments. For example, gray. Okay, it was gray with an A. Yeah, here we go. Now we got the same in black and white. What else can we try? Twilight, but it doesn't look that spectacular. Twilight. Yeah, like the movie, it is not really spectacular. And yeah, so if we want to have a look at what it could be, just type something that doesn't exist, like this. And now I show you the console, because now the exception that is raised is kind of important. Let me zoom. Yeah, supported values are accent, accent R, and here you can see all the supported ones. Okay, back to the original. Yeah, and we could also add a color map, but I didn't cover color maps yet. It is a topic I clearly should be covering soon. But anyways, now what we also can do is next to CMap, and for that we kind of need to slice something like 1040 and for the width and 1040 for the height. And mode is like, let's do 0 again. Now if we plot it, you see just we zoomed in too much, and just a mess of pixel. But with the input, what was it again? Interpolation, and be cubic. And if we run it now, you can probably see it's got much smoother. And again, like before, you can just type in something entirely wrong, and then you get the supported strings. Like, let's do something like Kaiser. Okay, I should maybe switch back to the usual. So here we go. Now with Kaiser, it gets smoother, but on a different level. Okay, so back to the usual design or usual code. Now again we have our picture, and the last thing I wanted to show is pretty simple. It is alpha. And alpha is by default set to 1. And as you can probably see, nothing has changed. But alpha means blending value. So 0 is transparent, so you can't see anything. Maybe I will show you alpha 0. Now as you can see, there's nothing left, and we can now use 0.5. And here you can see it is blended. It is like, got a little bit dizzy, not dizzy, but white, more. I don't know the right word for it, but you see the different output. So you probably know what I mean with alpha, with the alpha input. Okay, and I am already finished, I guess, because this 3 inputs, alpha, CMap, and yeah, this was my mobile phone. Guess it was, yeah, interpolation. And yeah, I hope I didn't cover it yet now. I didn't cover too much regarding that arguments because, yeah, if you really need them, you can dive deeper, but I guess most of the time you just need the, yeah, default ones. But yeah, it's kind of nice to know, I guess. And yeah, with that, I wish you a wonderful evening, nighttime, dinner time, breakfast time, supper time, whatever time it is in your country, or lunchtime. I forgot lunchtime. And yeah, see you hopefully on the next video. You can leave a comment regarding feedback, advice, suggestions, and so on. You can do a thumbs up if you liked the video, a thumbs down if you hated the video, of course. And yeah, see you in the next video. Bye bye. Hello, ho, ho, and yeah, welcome back to another episode of Python and another episode of Matplotlib again. And yeah, today we are looking at styles. And I'm not referring to my channel name, Doggy Styles. I am referring to styles of a plot. So yeah, let me fastly create a little plot. Like always, import matplotlib as plt, import numpy as np, nums equals numpy point random point, and it should be np, of course, np point random and rand int 010 size is 20, and now plt point plot nums and plt point show, really just to do it quick. And yeah, of course you have to point pyplot as plt. Now here we go. This is a really, yeah, common plot, just random numbers. But yeah, I don't wanted to show you how to plot something. That's why I made it pretty quick. I just wanted to add a style to this. So let's do that. And this is as simple as it sounds. plt point style point use, and now as an argument style like dark, I guess dark background. This should be a style, the usual dark mode style. Yeah, and now you can see it is dark. Pretty simply, I already showed how to edit the color of the plot itself and the color of the y and x axis. But yeah, here we have a style. So what styles are available? This is why I even made this tutorial, because you can, this is simply easy to Google. But to find out how to, how to find the different styles, I just, if you type in something that obviously doesn't exist, would be funny if it exists, but yeah. Now it doesn't exist, and now let me show you the exception. OS error dark lob is not valid package style, path of style file, URL of style file, or yeah, stuff like this. Library styles are listed in styles point available. So let's do this. Let's simply print plt point style point available, and yeah, he will show us this one, but it's not necessary. But what is necessary is what is in the console now, as you can see here. SolarWizLite classic test patch, stuff like this, and yeah, the list goes on, as you can see here on the bar. So back to usual. Okay, so if you want, so now we can simply do something like, and yes, can do something like use, and this is really a lazy method, plt point, if you don't know what style to use, point available 0. And this should give us the first style, which is, yeah, this one. Can do the third one, because we have a list. So styles available is a list. Yeah. This is kind of funny. So let's do something like 8. Okay. And now let's loop through the files and using the pause function. If you didn't watch the animate video, pause you can animate it because he's plotting again and again and again after that. So yeah, let's do something like while true, style point available, plt point pause. This should be 1 second, and yeah, let's do something like for I in range, range, plt point, style point available, and yeah, length of this. Length of plt point, style point available. Here we go, and yeah, of course, input should be E. And now let's run it. Yeah, now we should see, oh, you can't see that. 1 second. I will add it. So, but yeah. Guess, is this different? I'm kind of confused now. So let's do something like, let's increase the speed a little bit, 0.1 again, plot it again, and now, okay, this is interesting, because he's only using the color. Okay, so I just realized switching the style is not possible, but yeah, what you can do maybe is, let's get back to the old code. If you want to, yeah, use, you can simply do import random, should also be possible with NumPy, but yeah, style point use, random, come on, random point, not random, random point choice. Now as an input, plt point style point available. And now yeah, I hope you can see it. Now he should use a different style each time. Yeah, most styles are pretty boring, but yeah, now we got the dark style, and there are possibilities to import your own styles and stuff like this. Yeah, maybe I will do another video regarding this. And yeah, apart from that, I wish you a wonderful evening, dinner time, nighttime, whatever time it is in your country. See you and bye bye. Where's the button for stopping the video? Ah, there we go. Hello ho ho, and yeah, welcome back to Python and welcome back to Matplotlib. And yeah, it's kind of time to say goodbye, because this will be the last video of the kind of large series. There will follow some other videos regarding Matplotlib, but they are more experimental ones, updates, new features, videos covering new features regarding Matplotlib that will come in the future. And yeah, this will be the last video of the big tutorial series. Thanks for everyone who watched until yet. And yeah, so finally let's get this right. Today we wanna save plots as images. And for that, let's import matplotlib.pyplot as plt and do something like plt.show and plot something like plt.plot. Let's do a little one like, yeah, I divided by 100 to the power of 2 for I in range 1000. And yeah, perfect. Can you see it? No, I will show you 1 second or 2. Or even 3 seconds. But yeah, here we go. This is our little plot and we want to save this as an image. And the most simple way to do that is plt.save figure out or output, or let's say out point png. Should be supported, and if we rerun the code like this, we get the image out. So let's move that to the side. And yeah, this is you see, this is when you view images in pyplot in PyCharm, which is the IDE I'm using. And yeah, we got we got an image of the plot. Pretty simple, but yeah, you see it's identical to the plot, so we have an image. So yeah, pretty obvious. Can do that for bars, for pie charts, and all stuff like this. So let's see it with a bar, point bar, I for I in range, let's say 10, and I multiplied with 30, or for I in range 10. And color, let's do color equals let's first import random point choice red green for I in range 10. Now let's run our code again. Here we go. And yeah, this should also be now saved as an output. Yeah, here we go. Okay, so what can we also do? We can yeah, save it with different arguments. plt.savePic, let's call it hey, I'm also an output. Yeah, point PNG, and we can do something like, now we can change the face color. Can say green. Now let's again run it. Here we go. So the plot that is showed is this one. The image, 1 second, 2 seconds. I'll show you the image of the first output is obviously this. And yeah, hey, awesome output is he generated another picture. And this picture, yeah, has green edges. Or as you can see, the face color, as it is called, if you are looking at the argument, face color is green. And if we type something like, let's do it again, green transparent equals true. And yeah, let's say to let's say orange. I like the color orange. Now again, let's run it. Again, we got the usual plot. We got the output that looks like the plot we generated. We got, hey, I'm also an output. And this is now orange because, yeah, we used orange as a face color and transparent. So everything is orange except the bars themselves. But yeah, everything else is orange now. And yeah, you can try it for yourself. It's kind of good to know, nice to know if you maybe use a GUI and want to make, have users, want to have different users make plots for themselves using a GUI. And yeah, the common user just wants to save it, the plot they created as a PNG or JPEG. So really useful for that. I hope you liked the series. I wish you a wonderful evening, dinner time, night time, whatever time it is in your country. Maybe after this video I could possibly change my mind and add another part. Also, I said this is the last part. So don't wonder if, even if I told you this could be the last part, don't wonder if there's another part following. But if it's not the case, thank you for watching. Hopefully see you in another tutorial series I created. Bye bye.